are the farmers.
A reciprocating compressor compresses refrigerant vapor in a cylinder using a piston. In a way, reciprocating compressors are like automobile engines. The pistons are directly driven through a wrist pin and connecting rod from a crankshaft. Depending on their size, reciprocating compressors may have one or more cylinders. Multiple cylinders may be arranged in line, opposed, or in a V. In each cylinder, reciprocating compressors have both a suction valve and a discharge valve. These valves give the compressor its ability to pump refrigerant vapor against a pressure difference. They are usually located in the head of the cylinder, in passages connected to the high or low pressure side of the system. Let's follow the compression process in a single-cylinder reciprocating compressor during one complete revolution of the crankshaft. Starting with the piston at the top of its stroke, or at top dead center, the piston begins to move downward as the crankshaft rotates. Because both valves are closed, the downward moving piston reduces the pressure in the cylinder. As the pressure in the cylinder falls below the low side pressure in the suction line, the pressure difference opens the suction valve, letting refrigerant vapor flow into the cylinder. The piston continues down and pulls in more vapor until the cylinder is filled with low-pressure vapor at the bottom of its stroke. Once past bottom dead center, the piston begins its upward stroke. The suction valve closes. As the piston moves up, it reduces the volume of the space in the cylinder, increasing the pressure of the vapor. When the pressure in the cylinder exceeds the high side pressure in the discharge line, the pressure difference pushes the discharge valve open, letting the compressed vapor flow out of the cylinder. This continues until the piston reaches the top of its stroke and most of the compressed vapor has been expelled into the discharge line. When the piston begins its downward stroke, the discharge valve closes. The complete cycle then repeats during each revolution of the crankshaft. This is the mechanical positive displacement vapor compression cycle using a reciprocating
form a vacuum which draws air through the rotors and into a chamber where it can be measured in cubic feet or meters per minute. As air travels along the rotor flutes, the space becomes progressively smaller. Because the cavity between the rotors is larger at the inlet end and smaller at the discharge end, air becomes compressed.
It is mainly composed of three parts: an impeller integral with a shaft, a double lobe casing, and a distributing cone which puts in communication suction and discharge nozzles. The liquid, forced by the impeller vanes, starts rotating, and due to the centrifugal force disposes itself as you may see. Supposing to isolate a portion of gas and another of liquid, you will...
As the vanes rotate and retract, the chambers get smaller, forcing fluid to exit through the discharge port.
We have two lobes in these shapes. These are called two lobes, and we have a casing in which these two lobes will rotate. Air will inlet from this side and air will be outlet with this side. Now we will see the working of lobe pump or blower. Air will inlet in the casing and lobes will start rotating. Air will be compressed in the casing and it will be compressed and outlet on the other side. From this kind, air will be inlet and outlet will take place and lobes will compress the air or any fluid or pump the air.
The centrifugal compressor is comprised of the following key components: compressor housing, impeller, ambient air inlet, outlet, a centrifugal compressor uses an impeller to draw in gas at the hub and accelerating it radially by centrifugal force through a circular flute housing. The housing acts as a diffuser that converts high-speed, low-pressure air leaving the impeller to high-pressure, low-speed air.
Through the silencers and into the axial compressor. The inlet casing also provides access to the thrust bearing and the inlet journal bearing. Variable inlet guide vanes are located in the inlet casing directly in front of the first row of compressor blades. The vanes are used to regulate the amount of air entering the compressor. The circular operating ring actuates the guide vanes so that all vanes move in unison when opening or closing. Before each set of rotating blades is a set of stationary blades, or blade rings, that direct the air to the next set of rotating blades. The compressor blade rings have stationary airfoil-shaped vanes that direct the air to and from the rotating compressor blades. The rotating blades force the air into progressively smaller spaces as the air passes through the compressor. Heat of compression is generated in the air as it is passed through successive compressor stages. The compressor consists of 16 rows of individually removable rotating blades. Each blade is locked in place by a dovetail arrangement at the base of the blade. The rotor is made up of a bladed compressor spindle and a bladed turbine spindle that is bolted together to make one single shaft.